Okay, good afternoon. This is the last one. It's a bit different from the others. I've been stunned by the presentations we've seen so far, and all some beautiful demos. This is much simpler, but I want to show an application where WebGL is really, I think, going to be the next generation and really change how geospatial software is done on the web. A bit about me, a bit about where I work. I'm at Camp to Camp. We're an open source company based in Lausanne. We've also got offices in Chambéry in France and Vienna. We do lots of geospatial stuff, all open source based on libraries like OpenLayers, Mapfish, PostgreSQL. We have a business division. We have an infrastructure division doing lots of management of infrastructure in the cloud. Find us at camptocamp.com. So geospatial WebGL. Well, currently geospatial is one of the main uses of graphics on the web. But what we've got at the moment is pretty simple. If I look at existing 2D maps, this is OpenLayers. We have great data here, but all we can do is pan and zoom. That's about it. With WebGL, we can do a lot more. Now, first, why just 2D? Why does 2D matter? Firstly, it's very familiar. It's simple navigation. Most data at the moment is still in 2D. 3D data is slowly being accumulated, but at the moment, we have a lot of people who have a lot of 2D data and want to be able to visualize and manipulate that. It's also mobile friendly in 2D. Obviously, the demands on the graphics card, the demands on the battery, which is probably the main thing for mobile stuff, is much less. So by doing 2D specific WebGL code, we can get some real advantages here. We get the power of WebGL and bring it to mobile devices in something that's going to last all day. What can we do? I'll show you a demo in a sec. Well, here's the list. Let's go straight to the first demo. So this is the classic, I'll make it a bit darker. This is the classic 2D slippy map, but done in WebGL. We have exactly the same features in the normal 2D map, but we can start to do a few extra things. Our normal 2D maps, we start to get richer interactions, not just pan and zoom, but we can start to manipulate the map, rotations, etc. This is useful. You can imagine this on a tablet device. You can walk around, you can rotate the tablet and always keep the map pointing north. We can start to treat the data on the client side. So here we have mapping data which has come from an existing server. Let's go to somewhere we all know, like here. But we can use things like the fragment shader to do client-side manipulation of the images. So I can change the brightness, for example, simply contrast, invert, all these, even change the colors. All this running on the fragment shader on the client. And old school systems would have to generate different images on the server. This is useful particularly in 2D. We have various other effects as well. I'll come back to in a sec, because often a lot of 2D applications about putting multiple layers of geographical data on top of each other. We might have a base layer of a map, and then put on top of that extra information, for example, location of houses, airspace, whatever you want. You can, having this power in the client to be able to manipulate individual layers, the rasters of individual layers, allows us to compose this geographical data in the client and much more powerfully. Beyond that, the map guys, and the features already been mentioned, is that maps come in lots of different projections. And when you have data in different projections, with existing 2D libraries, you can't mix these data from different sources. Things just simply don't line up. With WebGL, we can use the vertex shader to do these reprojections in the on the client themselves. This is just a very simple one. We can even animate these things. And this is a very interesting application for geospatial guys because it allows them to mix data from different sources. So I'm going to this one. Let's check my list. The fifth point on there is, I know, an area that's very interesting to many people at the moment. With WebGL, we can use the GPU to handle millions of objects on the client side. We're no longer limited to the powers of our JavaScript virtual machines. We can use the GPU to help us out here. Here's a demo. Oh, let's just reload that one. That's better. This is another WebGL map, but these yellow dots here are geographical points which have been loaded from the server, and then we're now doing hit testing on the actual client side. Hopefully when I come up, yes, here, this is giving us the address of each of these houses. What I'm doing here, it's actually going back to very much old school techniques. I'm using the GPU. I'm doing obviously the main render to the image you see, but also rendering to a second texture where instead of storing the color, I encode in the color the ID of the object at that particular point. This means all the hard work of iterating over millions of objects is being done entirely by the GPU. We upload the data into the GPU once, and it's there, and we get very fast, very reactive, or instantaneous, effectively, mouse over interaction effects on the client. This will, I mean, here we've only got about 2,000 or 3,000 objects, which is already pretty much an order of magnitude more than what most JavaScript libraries can handle, and we know that WebGL we can go to millions and millions of objects. What I'll do now is show a little bit how this is very much a first prototype, this first one. The way it's done at the moment, I'll show you the problems that will come and you'll get to this, is that each tile is rendered individually. We draw each one to the final canvas one at a time. We can fall back to tiles from lower resolutions while we're waiting for this. I'll just do a quick demonstration of that. I'll turn off the effect. A classic effect while using maps is that when you pan, you need to wait for data to load coming in from the server. In WebGL, it's very easy to actually use a lower resolution tile while you're waiting for a higher resolution one to load. And the effect for the user is a richer interaction. So at the moment we're doing it this way, but it has a number of problems for doing this. They've already been spotted. If we just turn to this one, if I zoom in, let's go find this one. Plan this better. Hopefully you'll start to see. Yeah, we're just starting to see effects, tile effects here, that white line. We're getting seams between these individual tiles. And for some of the effects that we're doing where we're doing image processing effects to mix data from different tiles. Let's go back to that, it's probably the clearest. That's what I want. The edges between different tiles become very visible. The solution to this, and which you're going to see in OpenLayers version 3, is coming soon, is to actually use a two-step rendering process. We render first tiles perfectly to a separate texture, and then we resample that texture to actually create the final thing that we're going to view. What this means is that we have the control to line these tiles precisely in the texture. We can also then render the entire view with a single draw call with just 2 triangles. So it's super fast. We get further advantages for small manipulations when the user is just panning the map around a little bit or doing small rotations. We don't need to actually upload anything more to the GPU memory. Everything is already laid out. We just do a second draw call with the view slightly displaced. For panning, we can use techniques from old 2D scrollers. If you imagine that we're moving the map to the right, at some point, the green box we can see is going to go off the edge of the texture. We can use WebGL's nice wrap texture S, wrap text T, to actually just load a new column. If we're moving right, we just load the column of textures into this existing texture, and we get very, very high performance. Of course, this is great for compositing multiple layers. We use intermediate textures for each layer, and we end up with very, very fast compositing, and the final thing, just 2 or 3 draw calls to do the entire map. This also solves precision problems, which I'll demonstrate that these become obvious if I zoom in here. Here, in this particular model, in this particular prototype, the world is represented as a unit square, We're moving the camera over this unit square, and we find very quickly that we're at the limits of 32-bit floating point precision. You can see all these jitter effects here. And we can avoid that by going through this render to texture step. So this is the code, the demo, very simple demo there is on GitHub. It's raw WebGL calls. Out of interest, I started off using 3.js to do this, but 3.js is very much designed for 3D, and it's quite hard work to convince it to do 2D. So I fell back onto raw WebGL. Under the hood, it uses Google's closure library matrix functions and WebGL constants. The closure library, if you're not already using it, is a great piece of code. This generates very, very small JavaScript at the end. It also can say all your lookups of WebGL enums can be computed at compile time, which gives you more runtime performance. Using Google's closure compiler, which makes JavaScript more like Java, another great piece of kit. And for the image processing effects that you've seen have come from a different project, which is online at github.com. Not written by me. So overall, 2D maps in WebGL, it's a very exciting area. I think we're going to see a very fast transition to WebGL as being the standard back-end technology for all 2D maps. WebGL brings immediate useful benefits, particularly in the area of handling large vector layers on the client, which is very important for Geospatial. And look out for this functionality coming in OpenLayers 3, which is kicked off 2 weeks ago and will be coming soon. It's an open source mapping library. There you go. That's me. I'm at Camp2Camp.com. I'd love to speak to you about Geospatial WebGL applications. Thank you very much.
We have time for questions. Okay, there is a question.
Thanks. You make a really good point about being able to use thousands or millions of points now with WebGL, even for 2D.
Mm-hmm.
Have you seen anybody? One of the challenges, it's not really mapping. It's just like charting and graphing. You have the same problem. If you want to chart 10,000 points in an XY or something, you can't really do it. Have you seen anybody that's using it for applications like that?
I don't know off the top of my head. I'd have to ask Google. But it's a good point. It's another good use area for WebGL. And particularly, I think, combined with the techniques that, for example, the Nokia guys use for uploading data straight into the GPU without passing it in JavaScript. So it's very, very exciting area.
Any more questions? If there are no questions, I do have a question. You mentioned OpenLayers 3 is supporting WebGL. Can you tell us more about that?
Yes. So for those who don't know, OpenLayers is the standard powerful 2D mapping library. You can think of it a bit like the Google Maps API or the Leaflet API, but it offers much, much more support for lots of different formats, different map projections, which is not present in other libraries. Version 3 will be the next version of it, and extremely keen to have not just an HTML renderer, which works by basically putting images onto an HTML page and moving those in response to mouse inputs, but having a pure WebGL renderer for the advantages that I listed in the presentation here. Timing-wise, in fact, we're working on it at the moment. I've got a 2-day code sprint, another one coming up in Chambéry with OpenLayers developers tomorrow and Thursday. I know there's a lot of interest in it, so we should see OpenLayers 3 coming along soon, and it'll have lots of very exciting functionality.
Okay, thank you again very much.
Cool. Thank you very much.